Hello, 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 everybody. Root Beer here, and I'm going to be starting another University of Waterloo math contest. This time we'll be looking at the Fryer paper from the year 2019. So, if you're not familiar with the Fryer, Galois, or Hypatia contests, these are contests. They've just got 4 questions on them, but you do need to provide written solutions. So, you do need to justify everything you're doing. Let's take a brief look. So as I say, number of questions 4. The questions increase in difficulty typically as you go down. Now this is important. Each question worth 10 marks. You're going to probably want to try questions 1 and 2 before jumping all the way to what is supposed to be the hardest question, question number 4. So if you're actually writing the contest, you have 75 minutes or an hour and 15 minutes to write things out. Calculators are allowed, as with all University of Waterloo contests that I'm aware of. So when you're answering, you'll either see a light bulb or a pen to paper next to your question. If it's a light bulb, you just need to find the final answer. Okay? You don't actually need to show your work. But if you do see this symbol here, you do need to write out your full answer, justify things, say by the Pythagorean theorem, and then we factored the quadratic to get this. You just want to explain what you're doing and the calculations you're making. Okay, so I'll let you read all the instructions if that's something you're interested in doing. You can get a copy of this contest by clicking the very first link in the description down below if you don't want to just pause the video. And we're going to get into it with question question number 1, which we can see has 4 parts. 2 of them are light bulbs, just require final answer, and 2 of them we're going to have to write everything out. Okay? And a very useful fact, I don't think they've had this in previous years, this useful fact, because the sum of the first so many integers tends to come up a lot on contests. I think they've just started adding this, but 1 plus 2 plus 3, all the way up to a certain number, all the way up to, say, 5, instead of doing 1 plus 2 plus 3 plus 4 plus 5, 15, you can actually calculate it. There's a formula for that, and that tends to be quite useful. That's why they called it the useful fact. Okay. But anyways, I don't know if we'll need that for this question. I'm just pointing it out because I don't think they've had that in previous years. I'll have to go back and check. Okay, so 1A. A rectangle with dimensions 7 by 8 is shown in figure A. What is the perimeter of this figure? Okay. So starting off nice and easy. How do you find perimeter? You just add up all the side lengths. Now, since it's a rectangle, this length and this length are both going to be the same side, same length, so they're both 7, and we'll get an 8 over here. Now, you don't have to explain any of this. If you just want to put the final answer of 30, you're more than welcome to. Me, I like showing a little bit of work, so I would say it's a rectangle, so you got these sides. 7 plus 8 plus 7 plus 8 is 30. And that's your perimeter, and that's really all you have to do. You can put 30 in the box provided in the booklet if you're actually writing the contest. Okay, 1B. A 3 by 1 rectangle is removed from the corner of a 7 by 8 rectangle as shown in figure B. What is the perimeter of this figure? Okay. So, again, it's a light bulb. If you don't want to show any work, you don't have to. It's 8 and 7, and we cut out a 3 and a 1 this way. So what I would do is I'd probably just, draw a shadow version of the rectangle we cut out. Now I know this whole side here is supposed to be 8, and if we've cut out a 1, that leaves 7 here. And I know this whole side should be 7. All we did was just come along and cut out of the previous rectangle. But we removed a 3, so we put a 4 here. And so now, how do you find perimeter? You just add up all the side lengths. So you get 7 plus 8 plus 4 plus 1. I'm just sort of reading clockwise here. Plus 1 plus 3 plus 7. Okay, and we add those up, and it's kind of interesting. You'll get 30 again, because that didn't actually change anything. This 4 and this 3 make a 7. This 1 and this 7 make an 8. So while the area is decreased because we cut something out of it, the perimeter stays the same. And that's kind of nifty. All right, now C. Here's where we're going to actually have to explain ourselves, and you'll see what I mean when I start writing that up. See, a 4 by 2 rectangle is removed from one corner of a k plus 4 by k plus 2 rectangle, as shown in figure C. Suppose that the perimeter of figure C is 56. Determine the value of the integer k. All right, so here they're giving me the perimeter, and they want me to find the dimensions. So, okay. Draw our picture here. 2, 4, k plus, well, this should be k plus, yeah, k plus 2, and this one should be k plus 4. Okay. So what do we want to say? Well, I would do exactly sort of what I did in the last one. Fill in the missing rectangle. To complete the k plus 4 by k plus 2 rectangle. We do that right here. Now this is 4 and this is 2. So I'm going to color code things. So we know that this over here is k plus 2. So if we've already got a distance of 2, this must be k. So we lose 2 when we remove the rectangle, the 2 by 4 rectangle. So we are left with k. And now we can do the same thing down here. This side should be k plus 4, but we lose 4, so we're left with k. Similarly, we are left with only k on the side opposite the k plus 4. Now, I know 56 is the perimeter. They tell me that in the question. So it's k plus 4, k plus 2. Again, I'm just going to go clockwise. Ooh, dear me. Quite a morning. And then k down here, then 2 here, then 4, then k. When we add all this up, a 4, a 2, a 2, and a 4, that's going to be 12, and I've got 4 k's. So 4k plus 12. So now if I subtract both sides by 12, I'll get 44 is equal to 4k. And so k is 11, and that's all they wanted me to do. Okay? So I explain the sides that I don't understand. I put them into my expression for the perimeter that I know, and then I solve. So that's a good solid 3 marks right there. Okay? Explaining where I got everything, and then putting them into the formula. Okay. So what can we do now? So D part. 4 by 7 rectangles are removed from the corners of a square having side length 8n plus 1. Okay, interesting. And this is shown in figure D. Determine the largest integer n for which the perimeter of figure D is less than 1,000. Okay. So, I think sort of the standard thing that we're going to be doing is you look at the shape that they've got. That's sort of it. I'll do this usual extension. So I know I've got 8n plus 1, 8n plus 1. Okay. 4, 7, 4, 7, 4, 7. Now you may have noticed by now that the perimeter doesn't actually sort of change when we lose a rectangle. Because yeah, you lose this 4, but you gain a 4 here. You lose this 7 here, but you gain a 7 here. So the perimeter of the figure in figure D is still going to be 8n plus 1, the perimeter of the same square. And if you wanted to make that observation at this point, you probably could. So we've seen in B and C, so this is how I would write it up if I wanted to do that. If you're not comfortable doing that, if you're not comfortable saying, well, this is clear observation, you can absolutely just do what we did with the last one, okay? And give names to these sides here, things like that. That's fine. So as we've seen in B and C, cutting a rectangle doesn't change the perimeter. Okay, so for example, in that last one, with K and 4 and 2 and K plus 2 and K plus 4, or oh no, this is K plus 2, this is K plus 4. The perimeter was still K plus 4, K plus 2. This K and this 4 we could group together. And then this 2 and this K we could group together. Okay? So if you wanted to make that observation, that's fine. So figure D has the same perimeter as the 8n plus 1 by 8n plus 1 square. Now, what is it we're looking for? We want the largest n for which the perimeter of figure D is less than 8,000. Okay. So we'll say this perimeter is, well, it's a square. How do you get the perimeter of a square? Well, all sides are the same, so you just take one side length and multiply it by 4. So we'll get 32n plus 4. Now we want 32n plus 4 to be less than 1,000 or less than or equal to 1,000? Less than 1,000. So we'll set up this equation. 32n needs to be less than 996. And remember, I did say calculators are allowed. So we can just grab our calculator. 996 divided by 32. Oops. N needs to be less than 31.125. N is an integer. So largest n is going to be exactly 31. I put a little box around it to let them know I've got my answer. So the largest integer n for which the perimeter of figure D is less than 1,000 is going to be 31. If you want to, you can double check. 31 times 8 plus 1 is 249. Multiply that by 4 and you get exactly 996. Which is less than 1,000. Okay. So there we go. And that's question number 1 on our 2019 Friar paper. Up next, we're going to take a look at question number 2. So if you want to, feel free to try it. You can pause the video and try the question on the screen, or of course you can download a copy by clicking the very first link in the description. I'll see you for question 2 next time.